Hi everyone, and thank you for joining us in another webinar about how PlainID can support, protect, secure the agentic AI flow. This time we are going to focus on what can you do in order to prevent an AI breach and we'll show you some examples and speak about how that can be actually implemented. So I'm Gal. I'm the co-founder and CTO at PlainID, and also I have with me Mickey Martin, who's our VP of Sales Engineering. So we are both today, actually Mickey is going to do most of the work here. I'm just going to do a bit of introduction. Okay, so let's get started. So why are we here? This is a slide we like to show. I think every AI-based webinar we are doing, and it's really to emphasize the urgency of why we are speaking about that and what you should consider. Obviously, everyone speaks about AI. Not only everyone speaks about AI, but also everyone adopts AI or think about adopting AI. So agents are becoming your new employees, you might even say. You need to consider having a new set of employees, all agents. And they can do a lot of stuff. They can access data, they can do all kinds of activities and actions. And obviously, you need them as an organization. But in order to adopt them, as you would adopt your employees, you need to adopt them in a responsible way with the relevant controls in place. You need to know who those AI agents are, and more importantly, what they can do or what they should do. And you need to provide them with the sufficient boundaries in order to do so. And how can you do that? And the answer is, of course, with policy management for agentic AI. And that's why we are here. So we'll start with some of the challenges. Whenever we look at, and that's like, that challenge goes way back, even way before AI even started. Identities, digital identities have always been here, right? It started with your workforce identities, customer identities, partner identities, system identities, and now even agent identities. What are agent identities? By the way, this is another topic for a full webinar, so we are not going to talk about what are agent identities today, but let's currently assume they have an identity because they need to do something in the digital space, and in many cases, identity is needed for that. Anyway, we have all those identities, and identities are well defined and even well authenticated. But all those well defined and well authenticated identities should access. They should access all kinds of digital assets like data, microservices, APIs, and applications, right? They are there for a reason, and the reason is to operate in the digital space, consume all those digital assets that are out there. And that's the big question. How do you control that activity? So we have all those well-defined identities and very well authenticated identities, but eventually controlling what they can do, that is the challenge. And that's the focus of what we are speaking of. That is what policies, access control policies, are there to support, to manage that connectivity between all those identities to what identities can actually do. And a good policy solution would do that in a secure, simple, and extendable way. So that would be our focus. We are going to focus on AI flow, where two types of identities are there, right? We have both the end user identity and the agent identity. Now, those two identities combined, they should have access to data, services, APIs, tools, actions, whatever. And the question is how that is being managed and authorized and enforced. And that's the focus of what we do here. Talk about that challenge and talk about the answer to that challenge. And the answer is by implementing policies. Now, let's talk about what are policies and why they suit so well to the agentic era. So policies are basically a way to define the conditions, the rule sets, the the guardrails, whatever language you want to use, but basically who can access what and when. Policies have the ability to look at your identities, whether those are employees, end users, whatever, and agent identities. So combination of identities working together, what those identities should have access to. And if we consider the agentic flow, then obviously data is there. So that's a big item to consider, the data which is being accessed by the agentic flow. But it's not only data. Obviously, agents can also access tools, whether directly by APIs or by MCP or whatever. So tools is another big assets, a big topic to consider, assets that can be used by all those identities. There are other items, though, to consider. We also, and Mickey will speak about that, the questions that can be asked. So what questions can be asked, what can be used within the prompt, response that is then sent. So what can be seen within the response. So consider the full agentic flow, start to end, prompt, data, tools, and the response. That is, all of that should have the relevant controls or the relevant boundaries to the activity of the agentic flow. And that's what the policy is capable to provide. The policy is capable to act in that dynamic contextual way, to look at the identities involved in the current process, what is being accessed at this point of time, and then any other conditions, and apply controls accordingly in a consistent and standardized way. So this is just a quick PBAC reminder. Obviously, PlainID is an authorization company that utilizes PBAC as the main method to provide authorization controls across the technology stack, and obviously that also includes the agentic flow. Another thing I do want to remind you, just before handing over to Mickey, remember that authorizations, controls, whatever, they are not just a yes/no question. This is even more important when we look at the agentic flow, because agentic flow cannot just utilize a yes/no question. Sometimes more adapted controls should be implemented, like, for example, when you want to pull a set of data. Yes/no answers are not relevant there, right? Other controls are required, like filtering out the data or the documents which are being fed into the agentic process. Another example is when an agent is trying to reach a set of tools via MCP. So accessing an MCP server and retrieving all those tools, controlling the tools, again, cannot be cannot be just based on a yes/no answer. We need more advanced controls there. And that's where the policy-based access control method comes into play by supporting the patterns, all those patterns, permit deny, list of entitlements, data filtering, and data masking in order to optimize the ways of enforcement. Okay, so that was my part of introduction, and I'm switching to Mickey. Mickey, please take it from here.
Hey, thanks for handing things over to me. And, just also want to say welcome to everybody who's joined us on the call. One thing that we did forget to say at the beginning of this is that we do actually like live questions. So if you do have a question while we're going through this, feel free to type it in. It'll get over to us, and we'll try to answer them as we go along the slide, or answer them at the end of the show. And that being said, switching over to, how are we protecting AI and talking about different things that can go wrong when you're utilizing AI, right? Because I know there's a lot of hope, and I would say a lot of organizations out there hoping and pushing to use more and more AI to go faster, to try to keep up with the speed of business, which is always great, right? That's what we always want to do. We want to move fast enough to keep capturing the industry or keep capturing market share in whatever market that we're all in. But, to that effect, a lot of us, especially in the security world, are like, wait a minute, we got to secure it, right? It's like every time we have a jump in technology or a bump in technology when it comes along, right? If you remember quite a few years ago, right, when IoT started becoming more and more popular, and all of us in the security side are like, wait a minute, we got to make sure everything's secure first. And everybody was like, well, we'll just throw a bunch of IoT devices out there. And then we got amazing bot networks. I say amazing because they do some of the most, I would say, sophisticated DDoS attacks by just using the tiniest little devices across the world. But it all comes because of leaping before we look. Due to that, a lot of us we're looking at this AI thing, right? And it's kind of like, well, how are we going to protect it, right? What controls should we put in place? What controls can we even put in place, right? I mean, we all know the basis of security are the best practices of security, but for each thing that we're trying to protect, whether it be a database or a REST call or an IoT device, or in these new cases, LLMs and agents, they each have their own little nuances, right? Of what can be protected, what can be enforced, where can you do enforcement, right? The goal is always the same. The ideals, if you will, of the security industry are always the same, but the nuances between each technology is always a little different. And that's why we're talking about AI today. And to back me up on that really long statement, I do like to point out, NIST is trying to write, a new draft for AI type stuff, right? I love when NIST does things. But I am going to give them credit for jumping ahead and trying to write these new drafts, but also am going to pick on them a little bit, right? So if you've been reading while I've been talking, you'll notice that it says, hey, we need to implement and maintain robust cybersecurity measures and protect mechanisms, applying guidelines from established frameworks such as cybersecurity framework and risk management framework to ensure blah, 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 which is, in my word, in their words, fancy for, hey guys, we should copy the stuff that we already did for users and non-human identities. I do know if you go through the draft, they'll have a lot better examples in there, and they do a good job of outlining a bunch of different controls. Really nice read, but I do love picking on this paragraph because it's like, hey, follow the stuff we already wrote for humans and non-human identities, and just copy it over to AI, and we'll slap that on there and apply it. And it's like, well, yes, that's the idea, right? We want those frameworks, we want those ideas. We know that we need to protect and ensure confidentiality and integrity and all of this other stuff. But again, it's that nuance of how, like. So when we're talking about the different hows, the easiest thing to do is start breaking down an oversimplification of what goes on kind of when you're talking to an LLM, or when you're utilizing an LLM, or when your agents are interacting with different AIs, right? Let's just break that down. I know it's an oversimplified view for those of you who spend a lot of your time messing with AIs, but it does at least start to highlight some of the places where controls should be put in place and some of the places where controls can be put in place. So, just on the screen right now, I'm just kind of broken it down, right? You basically have, there's a prompt, right? You might be asking it to do something. You might be asking the AI to make an inference of some sort, right? An LLM in this case. After that, you can go on through, and if you see the next step here is data retrieval, that would be like if you're kind of like in a RAG model, retrieval augmentation generation, right? That means I'm going to go fetch a bunch of data pre-hand and send the data that's been fetched pre-hand with the question to the LLM. After that, you're inside the LLM itself, right? And inside the LLM, that's where all of that logic's going to get crunched and all that matrix math, and it's going to come up with some type of inference. But before it comes up with some type of inference, sometimes the LLM might decide that it needs more information, right? And that's where it starts to trigger things like tools and services. And you've probably heard of, the new hot button word, MCP servers, right? Those are all different things that the LLM or the AI can utilize to take actions, or, we'll simplify it today, gather more information. A good example of that is like if you ask ChatGPT, like, hey, what's the weather in Florida today, right? What's it going to do? You'll probably even see it now, especially in the new version, right? Where it prints out like, hey, I'm going to talk to weather.com and get the data, get the weather for you, and then summarize it, right? So it's basically triggering a tool, a web search tool in that case, and getting the weather from somewhere else so that it can, getting the data from somewhere else so it can make an inference for you. After that, the LLM will generate a response, and then that kind of feeds back to your application, and i.e. the end user viewing it, right? So you can imagine breaking that down. And we've already got it on the screen where the hot button topics are, right? But where would you want to put controls in place, right? Blocking unauthorized questions, right? That's an easy one. If you're not allowed to ask about sensitive data, maybe we don't let you ask about sensitive data, right? If you can't ask about so if you can't ask the LLM about, what's the social security number, maybe we just block the question all the way, right? Hey, what's Mickey's social security number? Just no, we're just not even going to allow that question to go in, right? It's always like if we talk about old protection type things, right? It's almost like pre-filtering, right? It's like, hey, select star on clients. No, we're not going to do select star on clients, right? You're not even allowed to ask about the entire client table. So we're just going to block you right here inside of the before you even talk to the database, right? Not much different. You're not allowed to ask that question. So I'm not even going to bother the microservices behind this. I'm just going to go ahead and block you here. Next thing is, especially when we're doing data retrieval, right? When we're doing like a RAG model, there's a couple of different reasons why you would want to put controls here, right? And the first control is that you might want to make sure that the information that is retrieved is scoped for the individual, right? And we're going to go through some more examples of this later and really break it down. But if I'm going to retrieve data to feed it into an LLM, I might want to make sure that the data is actually scoped to the individual. Maybe you're only allowed to see US data. Maybe you're only allowed to see global data. Maybe you're only allowed to see data that's been assigned to you, whatever it might be. The other reason that you would want to do it here, and we'll throw security out the window, but another reason to add in security at the data retrieval thing is because we all know the less amount of data that you feed to the LLM, i.e. tokens, the less you have to pay OpenAI or whoever you're paying, right? So not only is it a good idea to add security in here, which will of course lessen the amount of data that's fetched, but you do want to do data filtering in general, just so that you use less tokens and have to, reduce your bill. It's like 2 for 1, right? Security and lowering your AI bill. After that, once you're inside the LLM, for those of you who don't fool with them a lot, an LLM is almost like a black box, right? We aren't creating LLMs, right? You guys, for the most part, most customers that I deal with, right? They're not creating their own LLM. They're using one, right? You're using like OpenAI, or you're using like Gemini, or whoever owns Haiku, right? I'm forgetting the name of that one for a second, right? But they're the ones creating the LLMs, and you're just utilizing them. So in that case, the LLM itself, all that thing that's crunching the data and doing all the matrix math and coming up with the inferences at the end, it's kind of a black box. So you can't really add security directly into it. I know some people will add in things like system prompts to tell the LLM not to do something. But I always like to say that, LLMs, when you put in a system prompt, it's almost like a suggestion, because it decides what it wants to do, which is, a fun and dangerous thing. But it's like a human, like I was saying earlier, it decides what it wants to do. So in this case, it might decide it needs to reach out to tools and services and get extra information. And that's another great control point, right? Because now if it's going to reach out to maybe take an action, we could be able to tell it, hey, don't take that action. Or maybe it's going to reach out and get more data. And we've already filtered data in some places in our retrieval augmentation generation flow, the RAG flow. But, if it's going to reach out and get more data, that's another place where you want to make sure that you're adding in data filtering. Make sure the data is scoped for the LLM. Make sure the data is scoped for the user and the LLM together, interacting with each other, and the question itself, right? Make sure the LLM doesn't go fetch all the world's data about your customers when I'm asking about customers in the US, and I'm only authorized to ask about customers in the US. Right? And then last but not least, right, at the end, an LLM is going to make an inference. It's gotten all that data, and hopefully you've kind of done things like removed all the sensitive data using the other 2 controls that are there, right? But maybe you have, maybe you haven't. But at the end, the LLM is going to, generate an inference. It's going to generate a response, and it wants to send back to the user. And then rescanning that response, right? Checking that response again to make sure that no sensitive data or PII data accidentally ended up in that response. And then maybe even blocking the response or just masking some of the data in the response, right? Hopefully that brief overview, or that maybe it wasn't so brief overview of the simplistic flow and where you can put in different controls was helpful. And again, like I said, we do take questions live. So if you have questions, feel free to put them in there. But you could imagine some of the funny things that can go wrong with this, right? And always, it's kind of fun to say this, right? With an LLM, they do act like people. The only difference is you really can't put the fear of unemployment inside of an LLM, right? When we have processes and security requirements that we enforce on humans, right? We can enforce it through technology, policy-based access control, things like that. Make sure I can't see data that I shouldn't be seeing, make sure I can't see bank accounts that I shouldn't be seeing, make sure that I can't transfer money out of a bank account that I shouldn't be transferring on. And anything that we can't technology-wise enforce, we can paper enforce. For instance, if I were to take pictures of all the code inside of GitLab, right? You can't technology enforce me not being able to take pictures of everything using my cell phone, but you can paper enforce it, meaning that if I were to do that and it would leak, I could be fired. So, you put that little bit of fear in humans. You can't really put that fear inside of LLM. So you have to make sure that your controls are even tighter, right? And then you are also limited to the things that you can only directly enforce. Another thing about LLMs, or another thing that I like to point out is things that, we assume that people know, LLMs won't know. For instance, if you have a UUID for a user, unique, identity for a user, just a random bunch of numbers, and you have a social security number for a user, well, technically both of those are unique identifiers for a user. Us as humans, we just know that you shouldn't be throwing social security numbers around, right? Or if you're not from America, maybe a tax identifier number, or the other different types of numbers that you guys use in Europe that are sensitive, right? But for the Americans, social security number, we know we shouldn't be throwing social security numbers around, right? We know that. Yes, that's a unique identifier, but that's a special one, right? We really don't want to throw that one around. To something like an LLM, unless you've told it, prompted it, protected it some kind of way, specifically put in all your system prompts, a social security number and a UUID is the same thing, right? One's a meaningless but unique set of numbers. The other one is a very, very meaningful set of numbers, but they're both a unique identifier. So you can run into different things where if you're asking an LLM like, hey, and probably a question you wouldn't allow it to do, but if I were like, hey, who makes the most money at PlainID, right? It could return back my email address. It could return back someone's email address. It could return back a social security number if it had access to it, because to it, that's both a way to identify the user. I know it's kind of an oversimplified, blown out of proportion example, but those are the things, right, that an LLM can do. That's the same thing did. So we have to make sure that we put these controls in, and we have to make sure that they're tighter, and it can't just be a paper policy, if you will, just a paper policy like we can enforce on humans. We have a great question here. Should access be controlled at the API endpoint level? If so, would that be for both the user permissions and the LLM scope? Can you explain this in detail? Yes. Should access be controlled at the API endpoint level? The answer is yes. I'm going to be corny here, but you should control access at every point that you possibly can. One of the core tenets of zero trust, which we all strive to, approach, is to make sure that you are reestablishing trust at every digital interaction. So flipping through an API, if you will, and a microservice calling another microservice is just calling APIs, and a user utilizing an application. Like when I go to chatgpt.com and I type in a question and I hit enter, technically all that happened was an API, right? That screen right there, it just called an API and forwarded all of my stuff. When you build your own agents, you're calling APIs. So at the API level, you would definitely want to protect the things that you can protect at the API level, right? And some of the things that you can protect at the API level for an LLM side of the house will be a little bit more medium grain or coarse grain than what you could do in like protecting bank transactions and stuff when you're protecting an API. But going into that, you might want to do things like making sure that a particular user isn't hitting the endpoint of a different AI bot or a different AI agent that you don't want them being able to talk to. I would say broad example of this, but you could imagine like if I had two different chat bots inside of the company, and one is a chat bot for the developers, for them to be able to ask questions about what's in the code, and maybe like, hey, which logger should I be using, or hey, do we have a standardized logger that I should be using in this new function that I'm creating for a company, right? And then you have another chat bot, which is more for we'll say the sales team, right? We'll call the sales team out, where they can ask things about, what's their outlook look like, and what's currently in their pipe and things like that. So you've kind of made two different things, right? Two different chat bots, if you will, two different chat interfaces. Now, what you want to make sure is that the person in sales would not be able to trigger the endpoint for the chat bot for the developer side, right? You might have both chat bots, if you will, and both LLMs constrained to a point where the RAG side of it and the tool side of it are only using their respective stuff, like this chatbot / AI workflow over here can only use the tool that lets you search GitLab or GitHub or whatever, and a couple of other places. And the one over here for the sales guys, it's configured where it can only retrieve information out of Salesforce and use the Salesforce tool. And that's great because you've locked them down from that standpoint. But then you also want to make sure that as a salesperson, I just don't hit the other chatbot directly using an API, or hit the agent of the chatbot using an API, right? So a little bit coarse or medium grain, but you definitely want to put those controls in as well. Is there a good standard to have agents identity passed on MCPs or simply tools to have proper authorization controls, better audit log? Is there a good standard? I would say right now, what I've seen most people utilize right now is they are just passing around the access token JOTs that we've typically been passing around for microservices for forever. Agents are, and most part, agents are just special microservices at the end of the day. So that's what I see most people doing. I haven't seen anything really specific for the MCPs themselves. I do know there is some stuff using Spiffy, which is a little bit different type of authorization than what we're talking about right now, because Spiffy is going to be more like, can this agent call another agent type thing. A lot of the stuff that we're going to be focusing on is like, should this agent take this action, or should this agent get all of this data for this particular user type side? And on that side of the house, that's where you're mostly going to see people passing around the access tokens back and forth. But again, agents calling agents, tools calling other tools type thing, you will see a little bit more of the Spiffy side. Need both to, I would say, close all the current known gaps. Cool. And thank you guys for your questions. So to kind of break a little bit of and I know I've given some of these examples away already as I was talking through. And again, if you have more questions, keep them coming. But it's kind of like this, right? A policy design for agentic AI, right? What are some of the things that you can do with, PlainID specifically, but some of the things that you should have as policies that you could put inside of PlainID and start having enforced today? And I know I already talked about this, right? Where you can have John say, hey, show me employee salary, right? Like that's his prompt at the end of the day, right? So the type of things you want to enforce there is like, who can ask the question, right? Like John can, he's in HR, Sarah can, right? Maybe legal can. Sales probably doesn't need to know an employee's salary. How do you think we can support fine-grained permissions for the agent if there are use cases demanding it? So that's going to be from here on out. That's actually what we're going to be diving into. First, a couple of use cases themselves, like this one. And I know I've given some examples already, but basically a couple of these use cases and what should or shouldn't happen. And then a very crazy architecture diagram that shows you I would say decently good how you should do this inside of production. Right. So in this case, pretty simple, right? And you want to say who can go ahead and ask this question, right? And again, not a surprise on this type of thing, right? And this type of thing is a permit deny response, right? But the real question is how does that actually work, right? That is a permit deny. It's like, hey, that's pretty easy. I can say deny. It's almost like saying, hey, can Mickey do a get against /account /123? No, that account's not assigned to him. You shouldn't be able to see it. Let's block the rest columns, permit deny. But in the agentic world, right, you have a question, right? So it's like, the question itself is, show me employee's salary, right? Or can I see, can you tell me the average of an employee's salary type thing, right? So bringing that permit deny, can I ask this question to the agentic world? It does require some extra pieces. And for instance, that would be understanding the question itself, right? And the other side, can I get account 123, right? That's pretty easy. What's a get? It's a read. Cool. I know you're trying to view information about account 123. Let's block it, right? It's very, very deterministic. In this world, we have to kind of understand what the question means, right? Show me employee salary. That's weird, right? That's not a hard mapping to something. That's words that need to be interpreted, right? So in a lot of these cases, what you end up having to use are what we call these, or what we call category recognizers, right? And those are little AI flows, usually little tensor flows that help you look at the question and start realizing, oh, employee's salary, that's HR data, right? Salary, that's HR data. Employee sensitive information, right? So it's these little tensor flows are these things that we call categorizers, right? For categorizing the prompt are utilized so that we can start mapping these to things that a user may or may not have access to. are pretty cool. There's a couple of them out there, and with PlainID, we do have one that's built into our authorizer, which we'll talk more specifically about later, right? But that's always the first step. You have to start trying to bridge between the non-deterministic world and free world of language into mapped policies and mapped objects and digital assets that a user has access to. So that's how you can turn this question of language into a permit deny response. First, you categorize it. Oh, employee salary. That's HR data. Cool. Can this user see HR data? Yes, yes, yes. No for sales. Moving on to the next type of thing, right? Which data should support the question, right? So if I said, show me employees' data or employee salaries, right? Or show me an average of employee salary, right? That question could be asked by both Sarah and John there specifically, but of course it's very, very different context for them, right? In the other side of the world, right? I would just tack on some stuff to a SQL call, right? Hey, I want to see employees' data. Cool. Well, Mickey, you're in the US and the policy says that you can only see US employee data, right? And then we would just do that. Funny enough, in the agentic world, it's not that different as far as what we should do. Now, the enforcement's a little bit different, and we'll get into how to do the enforcement. But that's the general idea of it, right? Yes, you can see employee salary, but which employees, right? That's very, very specific. You want to make sure that you're locking down and making sure that a U.S. employee doesn't accidentally see all the salaries for Sweden, right? They're in HR, but they don't need to see Swedish data. They don't need to see the EU data, right? So in that case, if you remember, that would be the data filtering, but that would be applying to the things like the RAG side of the house. If you're using retrieval augmentation generation, right? Making sure that you're going through and filtering the data based on your vector database and your metadata that's tagged to it, right? If a document that has salaries inside of it is tagged with US salaries, then that's okay for John, but it's not okay with Sarah, right? And then manipulating the select statements, if you will, from that vector database that's going to fetch all of those different documents, or even if you're just prefetching it out of a database, right? Same type of thing, right? You want to make sure that you're scoping that data to the AI and specifically to the user in this case. And again, this is that one that gives you that double-edged sword of, now you're reducing the tokens that you're sending in. So your prompt just became cheaper because you applied security. One of the few times that we can say, hey, security is actually saving you money, other than trying to attach it to a breach and then telling you how much a breach costs, right? You can directly apply this to saving money on an AI. Now, last but not least, when we're going through here, right? It's when the answer comes back, right? When the tools are getting triggered. I always forget about the tools, right? Because I do a lot of the RAG stuff, at least when I'm playing with AI. But the tools themselves, that goes back to the permit deny side of the house, right? So you can imagine that if we didn't have a retrieval augmented generation type thing, we didn't have a RAG model in this case, I might just say, show me employee salary. And then I would have an MCP that would be hooked up to Workday data, right? Workday is an HR company. Workday data. And then the LLM could just decide it needs to go get HR data and just go get it itself. Those are the fun ones, right? Where you're really, really getting your AI to think for itself, if you will. It thinks it needs HR data, so it gets the HR data. The problem is now we have to stop it from getting it. Before, we were kind of already in the deterministic world, because when you're talking about a RAG model, you're in your guardrails, which is more on your application side than it is inside the LLM. But now we're kind of, we're touching on that LLM. The LLM is the one that decides which tools it should trigger and which MCP things it should trigger. You can tell it not to be able to trigger ones, but you can't, configure it to, hey, there's 5 tools here, and then only use 3 of them when you're talking to John. That's not really configuration that you can put inside of an LLM. You can say, don't turn on these tools. But once you've turned them on, splitting that hair per user, if you will, because that's the important part, is making sure that it's not only per the LLM, but it's per LLM per user type thing. Splitting those hairs, that's something where you need an MCP proxy in most cases, right? The ability, so that way when the AI or the LLM reaches out for the MCP and says, hey, HR MCP, give me all the HR data, right? You might say, oh, look, nope, we're not going to trigger this tool. I'm not even going to allow you to trigger the tool and microservice is usually what's under there. But I'm not gonna allow you to trigger the tool to go get HR data for the sales guy, Hiroshi in Japan, right? Oh, you want to trigger it for Anna? Cool. Now, a cool thing is we'll let you trigger it for Anna, but depending on the MCP, right, and your configuration, that's where you can also add in that filtering. Yes, you're going to go hit Workday, but let's only get the Swedish data for Sarah, right? And that's a deeper integration for fine grain when you're using your MCP tools, or sorry, your MCP servers and your tools and stuff that you've configured for your LLM. So, and again, those are all counting as tokens that go inside of your LLM. So, you know, security and savings on your project. And then last but not least, right, the question itself, right? When it comes back out, let's mask some PII or not. And this is always my favorite one, right? And I know right here it has some things for legal, right? Letting legal see PII, but that's the joke I always make with Social Security number. If I said, show me employee salary, the LLM could come back with, you know, Mickey makes X amount of dollars. Well, that's awesome. But again, to an LLM, a Social Security number and an email address are both unique identifiers for a user. So if it decides to use Social Security number because it had access to it, which I would say is a different problem, we should have made sure that the LLM never had access to Social Security number through many other means. But let's say they all failed, and the LLM used the unique identifier Social Security number because that's a unique identifier. So it just sends back, hey, you know, user, you know, 444-44-4444 makes this much money. Well, you know what? We really don't want to show that to the user, right? And that's where you use a different thing here. Again, because we're dealing with natural language again, right? We're going back into that non-deterministic side. We're going back into that fluent language side, right? And, you know, you have to use something called an entity recognizer. And an entity recognizer is, again, it's a little, we put quotes around the word AI, or more like a TensorFlow type thing, that looks at the paragraph, if you will, looks at the answer, looks at the inference that's coming back, and it scans through it real quick, and it recognizes entities, i.e. recognizes if something looks like Social Security number and says, that looks like Social Security numbers. Is this person allowed to see Social Security numbers? Right? And then if the person is or isn't allowed to see Social Security number, that's where you would do your policy side and your enforcement side to go, hey, a entity recognizer and guardrail. Let's replace that Social Security number with a bunch of X's, and then you can go ahead and send the response. One thing that I like about the answer, masking the answers, right? Because you always have two choices. You can mask the PII inside of the answer, or you could just deny the answer and send back some static response. I always personally like masking the PII, especially when you can't do it, masking the PII inside the answer, because when the answer goes back to the user and the data is masked, the user knows that everything worked appropriately. I asked for employee salary data. It came back with employee salary data. Something was weird in it, and it went ahead and X'd out some stuff. It accidentally tried to return back too much PII or things I shouldn't see, so something X'd it out. But I do know that the entire process worked. I know that the LLM didn't, or one of the agents or one of the MCPs just didn't fall over and now the whole thing's broken. I know it worked because I got an answer back, and it's just got some X's in there because of the masking pieces. Versus if you just do like you do at the beginning and you did something like permit deny, and it would look at it, see that there's PII in there and say, oh, the user's not allowed to see PII, and it just returns back error or unauthorized, right? The user might be a little bit confused. So being able to do things like mask PII inside of the inference, inside of that natural language that comes back is a very powerful thing for user experience, as well as your own sanity when it comes to people opening up tickets when they think it's not working. So, nice little jokes about breaches and case studies, and there's going to come some times where we're going to have accidental exposure of data, and there's actually been a few of them already, right? Accidental exposure of data through an LLM. But these were I hope these were a little bit more light. I would say light and fun instead of scary, like some of them. But those things are going to come, and we need to prepare for them, and we need to surround these LLMs, surround these agents with the controls that we can, right? Now, going to the controls and why we should do this and all the NIST stuff, other than all the really scary, hey, breaches are bad type thing, right? I always do try to bring things back to things like zero trust and identity first security, because I've been in identity a long time. And I know most of us are tired of hearing about zero trust, because zero trust is an asymptote that we approach, not a thing that you achieve, right? You're always trying to get to zero trust, but it's a goal, right? It's a journey. But at the end of the day, it's kind of the same thing, right? We've always said that, like, for users and service accounts and customers and all of this stuff, right? We want zero trust, and, you know, barring all the marketing and putting that to the side and just looking at the core, what zero trust is, like I said earlier in the talk, it's reestablished trust at every digital interaction, right? That's really what it is. So zero trust itself doesn't say anything about humans. It just says reestablish trust at every digital interaction, no matter what that is, right? Whether it be non-human identities, whether it be service, whether it be an AI, an agent, right? An LLM, it just says you need to make sure that you're reestablishing trust. Check something and check it again. Kind of like we were talking about, check the answer, check the retrieval, check the question, check the retrieval, check the answer, right? Check it and check it again. Make sure there's nothing coming out of here that you don't want coming out of here. So, and to the question that was on here earlier about how do we think we can achieve fine-grained permissions for an agent if there are use cases demanding it, hopefully I've given you an idea of the places that you would put the fine-grained permissions at, right? Where can you do the enforcement? Because my last slide here, if you will, is going to be a reference architecture using PlainID to actually do those enforcements that are in there. So hopefully that's answered your question so far. If not, please type in another one. Or clarify it. But flipping over to the last part, right? How can we reestablish trust, right, at every digital interaction when we are talking about an LLM flow? And this diagram is a bit more complicated than the one I showed you at the beginning. But this is kind of the idea of it, right? You have your input guardrails, right? Whatever that input might be. This could be a chatbot. This could be an AI agent, because even with an AI agent, you're going to have an input, right? Hey, please go move money for me. I don't think anyone's using AI to move money yet, but whatever. Hey, please go move money for you. You're always going to have an input, right? And inside of your guardrails or your code, if you will, for that particular microservice agent, whatever it might be, chatbot, right? First thing you need to do, we talked about it earlier, categorize the prompts, because that is natural language and we got to figure out what they're asking for. Are they asking about HR data? Are they just asking about the weather, right? That's very, very important. Once you have the categories, you want to authorize the categories. And like everything in PlainID, when we have an authorizer, like our guardrail here for this type of thing, it's going to reach out to the policy decision point inside of PlainID. All right, well, I know the categories and I got the user's JOT token, probably what we'll use, right? Well, I have the user's JOT token. Can this user ask about this category, Mr. PDP? In that case, all the PlainID normal stuff kicks in that you guys are probably used to if you've been to some of our other webinars. If not, we have tons of them out there that really break down this flow. But our policy decision point will basically look at the policies, and then it might talk to the PIP to go get more information, right? It might say, oh, okay, well, the JOT token has the user's email in it, but I need to see if that user's in HR. So let me go look inside of like the HR database to figure out if they are in the HR department before I answer this question, right? PIP will look up any extra information about the user and the questions and the data that might be needed for the policy to make for the policy decision point to make a decision. But it'll make that decision. In that case, that was a permit deny. Hey, you got permitted. Let's move on to the next part. Let's go retrieve some authorized documents that are relative to the question, right? That's your RAG model, right? That's your vector databases. That's your metadata tags around your vector databases, right? In this case, very similar thing happens, right? You're trying to do your RAG model. Let's add some filtering to that, right? Let's make sure that it's not getting too much data. Let's make sure that you're not getting unauthorized documents. Let's make sure you're not getting unauthorized data out of a database. Whatever it is that your RAG is going to retrieve before it hits the LLM, let's do that, right? And that's going to be things like we call our policy resolution endpoint, but that's going to be things like basically, in most cases, manipulating SQL queries or even, remove or even calling a REST call and when the REST call response comes in, removing objects out of the JSON object, right? We have a lot of breakdowns on how to protect data inside of PlainID, especially a really good webinar I did a while back with a guy named Vladi that works with us. Those types of things that we talk about when we're talking about protecting data and not in the LLM world, those are pretty much applicable for the RAG model itself as well, right? But you always want to make sure that whatever you're retrieving before you fill in the LLM has been scoped and authorized for the user. Goes into the LLM. Then you have your MCP proxy, right? So we have an MCP proxy / authorizer at PlainID as well, right? And if you're not familiar with MCPs, again, just think of them as like tools and microservices and REST calls that the LLM can make to go get more data or take an action, right? Just easy. Just think about them like a microservice out there, right? And just like a microservice, when we're protecting a microservice and calling an API, you can put a service mesh on top of it and put like an authorizer inside of Envoy, or you can put an API gateway on top of it and put an authorizer inside of the API gateway, right? And protect it and make sure that that microservice isn't triggered a certain way, or different data is retrieved out of that microservice based on policies and PlainID and our enforcement points. So if you're not familiar with the MCP world, just kind of think about it like that. The flow is pretty much the same. The architecture is pretty much the same, right? There's special nuances to the way MCPs work and how their protocol works versus like a generic REST call type thing, right? But the ideas and the enforcement is the same. Should you be able to trigger that microservice, i.e., should you be able to trigger that MCP server for this particular user? What data is coming back from that MCP server? What action would be taken when you trigger that MCP server? Should that be allowed for this LLM/this user, right? That authorizer reaches again out to the PDP, gets those decisions, and then, of course, we'll block or even add more filtering in, right? You might have an MCP server that gets data out of Postgres. You didn't do RAG, you're just going to let the LLM figure out what data it needs. So it gets data out of Postgres. So you might want to tack on some where clauses to that SQL thing, right? All different types of things that you would want to enforce inside of MCP. But again, it reaches out to the PDP, policy decision point, makes a decision, and then that authorizer that we have is responsible for the enforcement. And then at the very end, right, that output guardrail, that entity recognizer that we're talking about, back in that natural language world, right, we want to make sure that we are scanning the prose. We are looking at the paragraphs, right? We're utilizing something like a TensorFlow or maybe even a trained AI for this. They have plenty of them out there so that it can recognize all the entities, recognize if there's PII in that prose, recognize if there's something that looks like a social security number inside of that prose. Once all those entities have been identified, it's back over to PlainID. Can this user see these entities, right? Is there any masking I should apply, right? That's almost like when you're applying masking on columns, right? When you're using PlainID to mask data and you're masking columns or masking values in a JSON object, almost kind of the same thing, right? Where it's like, okay, well, should the user see this? Okay, maybe not. So let's just do all X's. Or should I just, mask the last 4? Or should they be able to see it because it's, applying to a US person, right? All that kind of masking thing mostly applies here when we're talking about authorizing the entities, and then manipulate that response, actually apply the masking, et cetera. And then finally, let that user see an inference. Not only are they authorized to see, but has been generated off of authorized data through the entire thing, in which we have checked and rechecked multiple times, reestablished trust in multiple places, that this is allowed to be seen. This is not data leakage. This is not actions that shouldn't be taken, right? This entire thing should have happened. And we have checked every bit along the way to make sure that the LLM didn't just get some extra information because it decided to trigger a tool for whatever reason it decided, or make sure that the LLM didn't just decide that an email and a social security number is the same thing because they're both unique identifiers. So let's return that, right? So well, I do want to thank all of you guys. I know that last one was, getting in a little bit into the weeds, but that's always the fun part of this, right? It's fun to joke about the bad things that could go wrong, but what we're really here to talk about is how do we solve this, right? How can we put these controls in there? How can we answer yes to NIST, whatever it was, 100? I'll forget the number again, but you get what I'm saying. How can we answer yes to these best practice frameworks that are being put in place, and yes, that we are doing our best, if you will, to protect and make sure that no data leakage happens when we're using these LLMs, which are, users with too much power. They think like humans, they make mistakes like humans, but unfortunately you can't threaten them like a human. If there's any more questions, I'll hang around for another minute or two. But that is the end of our presentation. I want to thank everyone who's joined us here today. Hopefully you guys found it useful. Of course, please feel free to reach out to us at PlainID, schedule a demo with us to see some of this stuff in action, right? Or dive deeper in any of the other PlainID functionalities that we have. But thank you guys again for joining us on this wonderful Thursday.
Excellent. Thank you, Mickey. I think we are good here, and we'll meet everyone in our next webinar. Thank you.
Yeah. So before we close out, and also to give anybody else another minute to answer questions, if anybody on this webinar is going to be at Gartner IAM, and what is that, like a week at this point, a week and a couple of days, in Grapevine, Texas, please stop by our booth and come visit us. We do have a PlainID booth, and I will be doing another speaking session at Gartner. I will say it'll be very, very similar to this one. But please come stop by our booth and dive in deeper with me or any of the other sales engineers or Gal herself. She'll be there as well. She's got more answers than I have.
Yeah. Thank you, Mickey. Okay. Excellent. See you all next time. Thank you.